types of food materials. Do you think that all of them taste similarly? No. Some of them are sweet, some of them are salty, some of them are bitter, some of them are hot. As such, we have different tastes of food materials. How do you think that this happens? How is that the different food materials taste differently? Right. So, as such, these food materials have different chemical compositions. So, accordingly, they are being classified into acids, bases, and salts. So, thus, today's topic is acids, bases, and salts. So, we'll learn more about acids, bases, and salts. Now, coming to acids. Now, as such, how can we define acids? For example, if I give you a curd to taste orange or vinegar, right? Or otherwise, you can taste tamarind also. How do you feel? They are somewhat sour in taste, right? So these substances which give that sour taste are acidic substances. So acid has been derived from a Latin word acria, meaning sour, right? So now the classification of acids. Now acids are thus divided into two types of acids, organic acids and mineral acids. Now organic acids are those acids which are found naturally, that is which are derived naturally from the plants and animals. They are weak acids. Examples of these are lactic acid, acetic acid. As such, you have mineral many acids, citric acid, malic acid. So these are some of the examples of organic acids. Now coming to the next type, mineral acids. Now these are the acids which are being prepared in the labs from inorganic materials, right? So these acids which we require, we have prepared in the laboratories using inorganic materials. Now these are somewhat called as strong acids. Example of these are hydrochloric acid, sulfuric acid, nitric acid. So all these form strong acids. Now we'll move on to the properties of acids. What does these acids consist of? What are the properties of acids? That depends upon the amount of water present in it. Now, as such, if you have visited a lab, there you have seen the acids, the names of the acids are written over the bottles in which they are being stored, and below that you have a diluted acid and a concentrated acid. So that differs in the amount of water present in the acid. Now, as such, if at all the water content is less, that P is being termed as a concentrated acid, and if at all the water content is more, then it is being termed as diluted acid. Now coming to properties of acid. Now never try to taste anything in the laboratory, neither a salt or a acid or a base. It's very highly dangerous. So kindly be careful when you are in the lab. Now, as such, when you're dealing with especially the acids. Now, coming to the properties of acids. Now, acids, as we have discussed before, are sour to taste, and then, if you can remember, you have seen a blue litmus paper and a red litmus paper. So, always the acids they turn blue litmus paper into red in color. Now, when they react with metals, right? They react with metals. That is, they corrode the metals like aluminium, iron. And this is the main reason why they are not stored in a metal container. Usually, they are stored in a glass container because the acids have a property to corrode the metals. So that's the reason they are stored in a glass containers. Now, acids, most of the acids are soluble in water. Most of the acids are soluble in water. Now, as such, when the acid reacts with the metal, then there's liberation of hydrogen gas. Now, when they react with the base, it forms a salt and a water. Now, when it reacts with a carbonate, it gives rise to a salt plus evolution of a carbon dioxide gas. So, as such, these are the properties of acids. Now, after that, we move on. What is the use of these acids in our daily life? Why is that we prepare all these mineral acids in the laboratory? So, these are some of the uses of the acids, especially hydrochloric acid. It is useful to remove rust in steel industries. Then it is used in several ways: wastewater management or treatment, purification of common salt, cleaning of boiler tanks, making food additives. So, these are some of the uses of hydrochloric acid. Then coming to sulfuric acid. Now, sulfuric acid is mainly used in the manufacture of fertilizers, then making some clothing fibers like your nylon, then as a cleaning agent for automobiles, electrolyte in car batteries, used in refining oil and also wastewater treatment. Then coming to nitric acid. Nitric acid, it is used in the synthesis of fertilizers, especially ammonium nitrate, production of explosives, purification of gold and silver, main component in liquid fueled rockets. Nitric acid is being used. Then coming to the weak acid, acetic acid. Acetic acid, it is used as a solvent, which is capable of dissolving some of the materials, and in food supplements as a raw material. So these are some of the properties of acids as well as its uses. Now we'll move on to the bases. Now, what are these bases? As we have referred over there, acids are sour to taste, whereas coming to bases, they are bitter to taste and also slippery to touch. So, these substances which are bitter to taste and slippery to touch is because of the basic substances present in them, and they are called as basic substances. Now, some of the bases are corrosive in nature. Okay, they result in skin burns. They are called as strong bases. Example of strong bases are sodium hydroxide. It feels we have this in our mind. Only acids are dangerous. They give that burning sensation. But some of the strong bases also are dangerous, especially to our skin. So we need to be careful in handling even these strong bases. Examples are sodium hydroxide, calcium hydroxide, potassium hydroxide, sodium phosphate, etc. Now, as such, along with the strong bases, you have weak bases which are not corrosive in nature, which are easy to handle. For example, ammonium hydroxide, magnesium hydroxide, copper hydroxide, as well as sodium carbonate. Now, moving on to the next part is properties of bases. What are the properties of bases as we have learned about properties of acids? Now, the properties of bases include they are bitter to taste, they turn red litmus to blue. If you have can recollect, acid turns blue litmus paper to red. Just the opposite, the bases turn red litmus to blue, and they are slippery to touch. Whereas bases dissolves most of the fats and oils. Some of the bases are soluble in water, and such bases are called as alkalis. So remember this point. Some of the bases which are dissolved, which are capable of soluble in water, they are called as alkalis. Best example is potassium hydroxide. Then some of the bases are corrosive as we have discussed. So they shouldn't be touched with bare hands. Now coming to the reactions between the base as well as the acid. When acid and base react with each other, that results in the formation of a salt and water. Whereas base, when reacts with a metal, gives rise to a salt and a hydrogen gases. Now next, coming to the uses of bases. What are the uses of these bases? Now here we have sodium hydroxide, commonly called as caustic soda. Now this sodium hydroxide is used in the manufacture of soaps, detergents, paper, textile and plastic industries, and also used as a cleaning material in water plants and food processing industries. Now the next you need to learn or remember the common names of these bases. Next is calcium hydroxide, is also commonly called as slake lime. This is additive in cement industry, in storage of foods, as it can absorb extra carbon dioxide. Main component in neutralizing the soil, which helps in enhancing the growth. Next comes ammonium hydroxide. Now, this ammonium hydroxide is used as a cleaning agent in the manufacture of fertilizers. Then comes magnesium hydroxide, also called as milk of magnesia, now used as an antacid to neutralize acidity in stomach, used along with HCl, hydrochloric acid, in fire extinguishers. Then lastly, potassium hydroxide, also called as potash, used in refining petroleum, making fertilizers, soft soaps, and is also making batteries. Now that is what is the uses of the bases. Now the next most interesting is the pH, the hydrogen ion concentration. So here you have a table, right? You have a table where it shows a chart wherein it is from 0 to 14. So this is a pH paper wherein 7 is the point where it is neutral. Below 7 we call it as a acidic nature, and above 7 we call it as a basic nature. A little more about the pH scale or pH paper what we are discussing about. Now this is the chart where you can see the colors also being mentioned over here, where this 7 which is in the center is what we call it as neutral, which doesn't show any change. Below 7, these are the colors which have been converted into, and we call them as acidic substances. Whereas towards my right side, it is all the basic or the alkaline substances. Now pH scale. What is a pH scale? Now this scale is a numerical representation. Substances with pH less than 7 are called as acidic substances, and the pH greater are called as bases. Now such substances like water, they have exactly 7. Okay, the pH scale reading will be 7, and that is what we call it as a neutral substances. Then coming to the next point in our class is the indicators. Now these indicators are highly colorful and you enjoy doing the experiments using these indicators. Now what are these indicators? Now they change the color. When you add these indicators, if you remember, you have been using iodine solution when you add it into the food material like your potato or dal or whatever it has been changed into bluish black. So as such, these indicators, they change the color when added to any acid or a base. So as such, when we add it to any acid or base, they change the colors. Now as such, indicators are of two types: natural indicators as well as artificial indicators. Artificial indicators in the sense we have prepared them in the lab and mostly we use it for our laboratory purposes. Whereas natural indicators readily available in our mother's kitchen or otherwise outside, which is obtained from the plants. Now coming to the natural indicators, they are turmeric, China rose, as well as litmus papers. Litmus papers already we have discussed. Now you know about turmeric. But China rose. What is China rose? Right. It is nothing but the hibiscus. Right? The hibiscus flower. Whereas artificial indicators are phenolphthalein as well as methyl our age, right? So this is about the indicators. Now, as such, we'll learn more about these indicators in our next videos. Till then, bye.